Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 2, Section 4, Modeling Linear Data. So I did put the notes for this first part on a Word document, and if you didn't get one from me, get a copy, please do, because the first part of this is, like I said, already printed out for you. All right, our notes start with learning about a scatter plot. So the first thing I'd like you to do is, from this table, take these points and we're going to plot them over here on the grid that's set up for you. And I just need to add a few labels here. So after I added the word minutes and put in the numbers, let's plot the training miles. The training miles were 100. Then you would expect that the run time would be 70 minutes. So plotted that here at 200 miles of training. The run time is going to be a little faster, 67, and so on. So we plotted these. Now it says to draw in a trend line that models the relationship between how many miles you train and your 10K run time. So if I made an attempt here to draw it coming right through all these points, the purpose of this was to kind of illustrate how imperfect humans are, and we are going to be doing these regression lines on our calculator. So this trend line is showing definitely that the more miles you train preparing for this run, the quicker, the faster your run time is going to be. And that's what a scatter plot tells us. What is the trend? And this is definitely linear because it's coming down in a straight line shape. And later on in the year, we're going to be looking at different shapes on the different scatter plots. So this middle part, we did draw in the trend line, and we could take time and try to figure out the b by looking at where it's going to cross the y-intercept and then try counting out the slope. But this exercise, the idea was to just show how poorly we do this, and we need our calculators. So we're going to learn here in just a moment, when we get down to the bottom of this page, how to take this information from this table, this list here and this, and we're going to put it into our calcs and have the calc give us this exact equation of the perfect regression line if we were able to draw it in. But our calcs are going to do that for us. So let's scroll down here to the vocabulary you need to learn. Scatter plot is the graph that illustrates the relationship. Whether it's linear, if it's in a U-shaped, it's quadratic. So we look at that, and we're going to be looking at that on our calc screen. A trend line is the line that's drawn in the best way possible to model the relationship between the two variables. And then we'll use that equation to make predictions. All right, the difference between interpolation and extrapolation. Interpolation, if I would just scroll back up here for a moment, would be like if you were the mathematician helping out this coach, and the coach wanted to have a prediction inside the data points. For instance, if the coach said, well, what if I have one of my athletes train by running 350 miles? And you could come over here and you could very comfortably use your graph here and give this runtime to the coach as what you would expect. Within the data points, interpolation is pretty accurate. Extrapolation, and if you think about kind of, does this make sense? What if the coach said, say, if I continued this trend and I trained an athlete and had them run 800 miles, would you expect this run time to just keep coming down and keep coming down and keep coming down? And once you get outside your data points, you can't say for sure. And common sense speaking, it would have to be no, that just because you keep training them more minutes doesn't mean the run time is going to keep getting faster and faster. Human beings do have a limit. So a conclusion you could draw is that when you are inside with interpolation, this would be much more accurate. than an extrapolation prediction, and mathematicians need to be aware of that. So now let's move into using our calculators to find these regression lines for us. And I would like you to record these steps so that you have them to refer to. It's sometimes hard to remember all the calculator buttons. So we have to find a place to enter our data. So first, you would press the Stat key on your calc, and then you would select the Edit function, which I think is the first thing that comes up. So you hit Stat, Enter. And what this does, it brings up the lists. And on these lists is where you enter the data. So you hit Stat, Edit, and then you would enter this under list 1 and enter this column under list 2. So you just punch 100, enter, 200, enter, and so on till all that data is on the lists. All right, the next thing you want to punch on your calculator, you would hit the second key, because the second function of the y equals key is the stat plot. And what we want to do here is turn on the stat plot so we can see it on the calc screen, and that way we won't have to make them on paper every time. So hit second y equals, and you're looking at that blue word stat plot. You need to select the first stat plot by hitting enter, and then move the cursor, the blinking cursor, over to the word on and hit enter to turn it on. So after the stat plot is turned on, you do need to adjust your window settings so that you can see the scatter plot, and I will help you with that as the year goes on so you can learn how to do that better. So in our particular example, our x's here go, the highest x, we have 100 and we go up to 600. So we're going to have to set our x max. Right now it should just be at 10 if it's at the default settings, and we just want to go a little more. You don't want to enter 600 or it'll cut it off. So let's say you do 700 for your x max, and the highest y we have is 70, so you can set your y max at, well, let's just say 80. So if you make those two adjustments in the window setting and then you hit graph, you will see this scatter plot on your calc screen. All right, the last step on the calc now to give us the regression line. We've looked at the scatter plot. We have seen that it's linear. So we hit the stat button, and this time we arrow over to the command calc because we want it to do a calculation for us, and then a whole menu comes up, and there's the bell. We want to look down on the menu that pops up here, and you want to find a linear regression line. So that's abbreviated linreg. So you scroll down, find linreg, and then you hit enter. It'll bring up a list of questions like what list do you want to pull from. For right now, we're just using the default settings of list 1 and 2. So you have to hit enter several times. Enter, 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 and eventually it displays the screen something like y equals ax plus b, and it tells you what a, it tells you the slope, and it tells you the y-intercept, and you have to plug them in. All right, next term we need to talk about is correlation, and we are looking at linear correlation in this chapter. Correlation means how close the data points are to the trend line, how tight the data fits the line, because how close it is to the regression line that we find is going to greatly affect how good our predictions are. We need a way to measure that. So there's two measurements. One is the correlation coefficient, and this is called R on the calc. This numerically describes how two variables are related. With a positive R, both variables are either increasing or decreasing together. And if it's negative, then one is increasing while the other is decreasing. The other measure that we use is called the coefficient of determination. This one is more commonly used, this R squared, because it gives us a percent of how tightly the data points fit the regression line. This is really important. The better the fit, that would be the higher the R squared. Like a very high R squared would be 0.9. If it's really close to 1, the better your predictions will be for whatever project you're working on. So a perfect fit, an absolute perfect, if we had some data points like this, if it was here, here, and here, and then we had the calculator drawing the regression line and it touched all three of them perfect, this is an R of 1, an R square of 1, 100%, all of the data points lie exactly on the line. Here, if we have an R of negative 1, that means that one is increasing while one's decreasing, might look something like this. And then if the calculator drew in the regression line, again, it would hit all three of them perfectly. This very rarely happens in real life, but this is a perfect negative 1, R squared is 1, 100% of the points lie on the line. You could make very good predictions with that type of an R squared. All right, in this next example, I did my best to set up a set of data points that would have an R value of approximately 0.7. So here the regression line would come through here, and you can obviously see it's trending upward and it's in a linear fashion, but the data points are getting sort of far away from the line. Our accuracy of our predictions is going to go down. We'd have an R squared of 0.49, not fabulous. Here, again, tried to spread them out a little more. If the calc drew in this regression line, it might come in like this, even further away from the regression line. Our R squared is getting worse and worse, 0.36. Not good predictions will result from this. All right, the next term is outliers that we need to discuss. These are points that are way far away from the trend line. And sometimes in a real life situation, there's a reason that they happen. Sometimes we include them in our calculations and sometimes not. It depends on why they occur. So we'll discuss this in class. You may throw them out if your equipment malfunctioned, for instance. But just because you get outliers doesn't mean you always throw them out, because sometimes you have some real wild sales numbers. The sales are way high and way low. You may want to discuss the reasons for these huge differences. But this is a bit depending on what's going on. Now we're going to look at how do you get the calculator to display the R and the R squared. These are a real pain to calculate by hand, so we're going to use the calc as our tool. The way you turn this on, we need to go to the catalog, and the catalog is the second function of the 0 key. So you hit second 0, and a huge list will pop up. And we will be looking for the diagnostic on. Now it's a long list, and if you do not want to scroll through the whole thing, you can jump to the D's in the list by using the alpha key. The letter D is the green function above the x to the negative 1 key. So if you hit alpha and you hit x to the negative 1, I believe you have to do it twice in some calcs. So if you go alpha D, you can jump in the list right to the D's, and then it's just a little bit of scrolling to find diagnostics on. Once you get there, hit enter, and then it'll bring you to the home screen, and it'll ask you, do you want diagnostics on? And to turn it on, you have to hit enter again until you see the word done. Then you know you did it. So now that the diagnostics is turned on, you go back to Stat Calc and select your linear regression line. And now on that LinReg screen, you will see at the bottom, it'll display the regression line just like it did before, but at the bottom it'll have an R equals and an R squared equals, and it'll give you those values, which is very nice because it's a pain to calculate by hand. So that's how you will find when you're asked to do the correlation coefficient or the coefficient of determination. All right, so now you have all the knowledge you need for section 2.4. All right, have fun with that.